Dart School presents Simplifying Fractions 1. When working with algebraic fractions, you should remember that they are like numbers. Only because they can change or their value is not known to us is why we use the x's, y's or the z's. And therefore, the rules of simplifying fractions with algebraic expressions is exactly the same as those of simplifying fractions with constant numbers. To add or subtract, you find the LCD or the least common denominator of the fractions, and then just combine them in the end when you have all of them on the same common denominator, just like you would do with normal numbers. To multiply or simplify fractions with algebraic expressions, cross off common factors between the numerator and the denominator, just as you would do with numbers, and then multiply the remaining factors. And when you want to divide, swap the numerator with the denominator of the divisor and change the division sign to a multiplication sign. And that's nothing new as well. Let us look at a few simple examples at work. Let's say you want to simplify the fraction 3x over 3y. Now if you look at the numerator, that's 3x, which means 3 multiplied with x, or 3 times x. And similarly, the denominator is a 3 times y. The 3 is the common factor, therefore cross them off. The final answer is x over y. That's the simplified form of 3x over 3y. Similarly, if you have something like az over bz, this time the z and the z are the common factors, so you want to cross them off. A times z over b times z, z get crossed off. That's another way of saying that z over z is 1. Cross off means this is a 1, this is a 1. So the final answer is a over b. Easily done. Let's say 3y over 5 times 2x over 3y. Now there's something called the commutative property in multiplication that tells us that when two numbers are multiplied, the order in which you multiply them doesn't matter. For example, 2 times 5, that's 10, is the same as 5 times 2. So when you want to rewrite this as the product of the numerators, 3y times 2x over 5 times 3y, you want to take advantage of this. It's called the commutative property. Commutative property of multiplication. And then you can actually rearrange these so that the 3y and this 3y, they actually form one single fraction. What I mean is, I just rewrite this as 3y times 2x over, just swap these two factors, 3y times 5. Now this 3y over this 3y, that's one whole. 3y over 3y, anything over the same thing is 1, provided that number is not 0. So 3y cannot be 0, which means y cannot be 0, and that's pretty obvious. Otherwise this whole thing wouldn't make any sense if you have a 0 on the denominator. So if we assume that y is not 0 and therefore 3y is not 0, this becomes one whole, and therefore the answer is just this 2x over 5. And you can just do all of that in one single step. The moment you look at a 3y on the numerator, no matter where on the numerator side that is, and if you see the same thing on the denominator of 3y, so it's like saying that the factors on the numerators is one single team and they're playing a game with the factors on the denominator. So you can cross off anything from the numerator team with anything from the denominator team. Doesn't matter where they are. And that works because of this commutative property of multiplication. Can we try another one? And I'm just going to make this a little more tricky. Not much though. 4x over 9z times 25y over 12x times 3z over 5y. How about that? The first step, as usual, is to reduce or cross off common factors from the team of numerators, this team, with the team of denominators, which is this team. So we have a x here and a x here. We have a y here and a y here, and we have a z here and we have a z here as well. But that's not all. We have a 4 here, we have a 12 here. Now if you think about 12, 12 is nothing but 3 times 4. And therefore you can cross off this 4 from the 12 with this 4. Similarly, 9 is 3 times 3. So you can cross off one of the 3's from the 9 with this 3. And 25 is 5 times 5. Therefore you can cross off one 5 with this 5. So what are we left with in the end? There's nothing here. When there's nothing, remember, it indicates it's a 1, not a 0. We have a 5 here, and then that's all on the numerator. On the denominator, as I can see, there's a 3 here, there's another 3 here, and that's all. And the final answer just simplifies to 5 on the top, 3 multiplied with 3 on the bottom, which is equal to 5 9s. As plain and simple as that.